A small shop owner has bought in the Santa or in any Raitu Bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are Swaras. We are top on the Everest. Congratulations.
I want to be a leader.
గుడ్ ఈవినింగ్ చిల్డ్రన్. మిమ్మల్ని కలుసుకున్నందుకు నాకు చాలా సంతోషంగా ఉంది. ఈ ప్రోగ్రాం ద్వారా మీతో మాట్లాడే అవకాశం కల్పిస్తున్నందుకు ఎంతో ఆనందంగా ఉంది. మనం గణితము అనగానే చాలామంది ఇబ్బంది పడుతూ ఉంటాం. కానీ అన్ని సబ్జెక్టులలో గణితమే అత్యంత సులభమైంది అని చెప్పచ్చు, మీరు ఆ కాన్సెప్ట్స్ని పూర్తిగా అర్థం చేసుకుంటే. సో కాబట్టి మీరు ఏం చేస్తారంటే, ముందుగా ఈ కార్యక్రమాల్లో రోజు మీతో నేను మీ యొక్క కాన్సెప్ట్స్ని చెప్పడమే కాకుండా ఈ కాన్సెప్ట్స్పై ఉన్నటువంటి ఏవైనా డౌట్స్ కానీ లేకపోతే ఓ సమస్యను ఎలా సాధించాలి అనేటువంటి అంశాలను కానీ మీతో ఇంటరాక్టివ్ మోడ్లో షేర్ చేసుకోబోతున్నాను. కాబట్టి మీరు ఈ కార్యక్రమంలో అందరూ హ్యాపీగా పాల్గొంటారని నా యొక్క అభిలాషం. So before taking all the classes, I am taking the first opportunity on number system. మొత్తం మనం గణితంలో ఒక 5 ఏరియాలను తీసుకోవచ్చు. There are 5 areas, especially one is a number system, second one geometry, third one algebra, fourth one arithmetics, and fifth one data interpretation. ఈ కార్యక్రమం ద్వారా మీకు కాన్సెప్చువల్ క్లారిటీ ఇవ్వాలనేటువంటిది మా అభిమతం. అందుచేత మీకు ఈ కాన్సెప్ట్స్లో ఎక్కడైనా ఏ సందర్భంలోనైనా సమస్య అరైజ్ అయితే అది నాతో మీరు షేర్ చేసుకోవచ్చు. ముందుగా నెంబర్ సిస్టమ్ గురించి ఆలోచిద్దాం. ఓకే, ఈ నెంబర్ సిస్టమ్ గురించి మీరు చూస్తే సుమారు ఒక 1000 సంవత్సరాల చరిత్ర ఉందని చెప్పచ్చు. In 19th century, the zero was introduced by our Indian nation, Indians. మనము వాడేటట్టుగా ప్రపంచంలో ఎవరు కూడా ఈ జీరోని ముందుగా వాడలేదు. మనకు చాలా సిస్టమ్స్ ఉన్నాయి, నెంబర్ సిస్టమ్స్. అందులో అతి పురాతనమైనది బాబిలోనియా నెంబర్ సిస్టమ్. వాళ్ళ సిస్టాన్ని సెగ్జాస్మల్ సిస్టమ్ అని అంటారు. Actually, they are taking as a 60 as the base. Our system is called decimal system. మనము 10ని బేస్గా తీసుకొని నెంబర్ సిస్టాన్ని డెవలప్ చేస్తాం. ఓకే, ముందుగా వీటన్నిటిని గురించి చర్చించుకునే ముందు మనం ఏదైనా కొన్ని వస్తువులని సంఖ్యను కానీ లేకపోతే వస్తువుల సంఖ్యను కానీ లేదా పదార్థాల సంఖ్యను కానీ, ఇఫ్ యూ వాంట్ టు సే ఎనీ a number of objects, we want to count them. There are 4 fans, 3 tube lights, 10 chairs, 1 water filter. Like if you want to say, if you want to represent some articles in terms of some numericals, those numericals are abstracts. 1, 2, 3, 4, these are numericals to represent how many are there. So we are using those things just for counting, hence we call it simply those are counting numbers. మనం లెక్క పెట్టడానికి వాడతాం కాబట్టి ఆ సంఖ్యల్ని మనం గణన సంఖ్యలు కౌంటింగ్ నెంబర్స్ అంటాం. Generally we are using these numbers for counting purpose naturally. So once you say naturally, so we can call those numbers as natural numbers. So we know it very clear. The natural numbers are the counting numbers simply, and we can represent those numbers as n is equal to 1, 2, 3, 4 and so on. Okay, these are the numbers, natural numbers which are used for counting. Okay. So, if you want to say some numbers, we are using some numericals, say 3, 4, 5. If there are more number, we can say lakhs, we can say crores like. If there is nothing, there is no, what you call it as for example, in your classroom, is there any water filter, I asked. If there is nothing, how you are going to represent? Or you are in your dormitory, how many ACs are there, if I ask? If there is nothing, then how you are going to represent? If you want to represent to nothing, generally we will use a numeral called as 0. అక్కడ ఏమీ లేదనుకోండి, మనం లేని దాన్ని చెప్పాలి అనుకోండి, రిప్రజెంట్ చేయాలనుకోండి, జనరల్గా మనం ఏం చేస్తాం, 0 అని వాడుతున్నాం. దిస్ 0 వాజ్ introduced by our Indians only. Actually 0 is derived from the Arabic word called safaria. Safaria means nothing, empty. So simply we represent with a numeral, call it as 0. Means 0 represents for nothing. Okay. So if you want to represent for some values, we have some numbers. If you want to say any number, we have the numerals. If you want to say nothing, we have the numerals. That is 0. Nothing, something, anything. So if you want to say in a holistic way, those numbers are called as whole numbers. So we represent the whole numbers as, so W, this is a whole. So how you say this is whole number? Simply we will call it as 0, 1, 2, 3, 4 and so on. So when you include 0, the natural numbers, generally we call it as whole numbers. Okay, it's very good. And for example, you want to purchase one article, you went to a shopping mall. Generally if you see any shopping mall, మీరు చూస్తున్నారు కదా, రిలయన్స్ డిజిటల్స్ అనో, లేకపోతే రిలయన్స్ షాపింగ్ మాల్ అనో, బిగ్ బజార్ అనో, ఇలా డిఫరెంట్ షాపింగ్ మాల్స్ మీరు చూస్తున్నారు కదా. There are nearly 4 or 5 floors there. So in 5 floors, so many articles are available. So many customers will visit there. So if you want to visit that particular place, they will travel by either car or any vehicle. So they want to park them. So they want to park it. So where they are going to park it? Some place is required. For that reason, the cellars are developed. You know that very well. Cellars ni chala varaku manam chustu untam. When you entering into that particular shopping mall, we have lift system. Everyone knows it. When you are in lift, what your observation? When you see that in the lift there is 0, there is 1, 2, 3, 4 like, correct? We have when you see there is 0, 1, 2, 3, -1, -2. So what is this -1 and -2? What is this minus 1 and minus 2? Generally the question will arise. So, that lift, in the lift system generally they are used as 0 represents the ground level and first 1 represents the first floor, 2 represents second floor, 3 represents third floor in upward direction. Okay. When you come into that, in cellar also we have 2 or 3 floors. If you want to represent those floors also by a numeral, generally what we are do? We will represent with the same number because it is the first, second, third. So, there is some property is required. What is that property? We have to show that those floors are above the ground level, above the ground, and these floors are below the ground. So, how you are going to represent that? So, below. So, for that we are representing minus 1, minus 2 or minus 3. This minus is not for the numerals, this minus it represents only the property. So, here it arises. For example, I have 2 rupees, okay. That is we can represent with one numeral. I borrowed 2 rupees from the other people. How I am going to represent? I have 2 rupees, I borrowed 2 rupees from the other people. How we are going to represent the same 2? When I have it, then we will show that as like plus 2. When you borrowed it from any other people, means we will represent with minus 2. Clear? Okay. For example, if the temperature, when you take the temperature, so at room level temperature here at 23 degrees Celsius or 24 degrees Celsius, it is okay. When you go in western countries, there sometimes the temperature will be less than 0. There may be a minus 2 degrees Celsius or minus 3 degrees Celsius or something else. So, here the negative sign requires to represent lesser or downwards some particular cases. So, if you want to represent these things also, generally we will use this negative sign. So, here the necessity arises that to represent some quantities, some positive sign required, some negative sign required. So, when you include these signs, we have the 3 kinds of numbers, the numbers with positive sign, the numbers with the negative sign and the number 0. So, means we have so on minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. These are called, of course, when you call it as a negative numbers, and these are called the positive numbers, and 0, 0, negative and positives. All these we call it as simply as integers, clear, as integers. Okay. Simply we will represent with I, clear. Okay. So, for you actually these what is the words in Telugu not necessary because all the children are English medium children. So, that is the reason I am not saying some of the words, actually the words are different. We call it as Sahaja Sankyalu, Purnankalu, Purna Sankyalu, those words, but this is the usual words. Okay, that is good. So, in our class one of the children is going to celebrate his birthday. He brought a cake and he want to distribute all of them to you. How you are going to distribute it? There is only one cake, there are 30 children are there. So, we are going to divide that 30, that of course, the total cake as 1 as 30 parts. So, part. So, each children will get part, not the total cake or whole cake. So, you want to represent for this part, there is one number is required, am I correct? Okay. For example, you have one apple, there are 4 children. So, you want to divide that apple into 4 equal parts, then how you are going to distribute it? I will show it in a rectangular process. Instead of that, say I divided into 4 equal parts for example. So, means there is one rectangle which divides into 4 equal parts 4 equal parts, means here, so each part is represented as 1 by 4. When you consider 2 of the 4, we represent it as 2 by 4. When you consider 3 as the required one, we consider as 3 by 4. When you consider 4 out of 4, means you are considering the whole, that is 4 by 4. Means what you understand it? The whole also can be expressed in terms of a fraction, correct? So, the whole is nothing but here 1. We are going to express as 4 by 4 because you divide it into 4 equal parts. So, here this is 1 by 4, 2 by 4, 3 by 4. For example, if there is a one part thing, we divide into 3 equal parts. So, each part how we are going to represent it is as 1 by 3. Each one is 1 by 3, 1 by 3 or 1 by 3, 1 by 3 like. So, totally, so if you consider 2 of them, we call it as 2 by 3. If you consider 3 of them, it is 3 by 3. If you consider 1 of them, it is 1 by 3. So, what you understand this is 1 by 3 or 2 by 4 or 1 by 2, all these are called fractions to represent a part. All of you know very well. So, the top one is call it as a numerator and the next one is call it as a denominator. So, numerator and denominator. So, very clear. So, here how many parts you are going to consider among the total parts. That's so here if you take 1 by 3 means that there are 3 parts. Among the 3 parts you considered 1 part, so we can represent as 1 by 3. This is called fraction. Okay. So, here there is whole and part, means the whole represented by, already you learned it, it is an integer. And when you consider part, which are fractions, the whole and part means integers among with the fractions, we call it as rational numbers, rationals. Okay. So, we know it very well, these are the rationals. What meant by rational? See, there is a conceptual conflict in rational numbers. So, previously you learned that a rational number is a number which is in the form of p by q, where q is not equal to 0, where p and q are integers, p by q, where q is not equal to 0 and q and p belongs to z plus, means integers are z, you can say z for example. So, they said previously you learned as a definition. Then when you asked it, so is 2 is a rational number or not? Generally the children know, so how you are going to feel that it is not in the form of p by q. So, then you hesitate to say whether it is a rational or not. So, children please understand that. So, the rational number is nothing but it is a combination of integers and fractions. So, we can consider this all these as rational numbers. So, 2 is a rational number, 1 by 2 is a rational number, is it clear? And 2 and half is also a rational number. 2 is a rational number, 1 by 2 is a rational number and 2 and half is also rational. Okay, what is the difference between these 3? 2 represents 2 whole parts. And what half represent? Half represent means here a part of one whole which divide into 2 equal parts. What is 2 and half represents? Means there are 2 whole parts and 1 half of the part of the whole. Is it clear? ఇప్పుడు మనకు 2 కి 1 by 2 కి 2 and half కి ఉన్నటువంటి తేడాని మీరు క్లారిటీగా గుర్తించగలిగితే రేషనల్ నెంబర్స్ని ఈజీగా మీరు ఐడెంటిఫై చేయగలుగుతారు. క్లియర్? See 2 means here 2 whole parts, రెండు తీసుకున్న 2 boxes. Okay. Half, you divided one box into 2 equal parts, that is okay. And 2 and half, there are 2 boxes, already you have one more half box, you know, when you add it, that is 2 and half, is also rationals. Clear? So, of course, you learn it as half as a proper fraction and 2 as a mixed fraction. Already you know that there are some proper fractions, improper fractions, mixed fractions, all these things. So, all these are called it as rationals. Okay. Previously what I am going to say, say here when you wanted, already I said our system is decimal system. Okay. Now no one is using the paisas, but we are using in calculations the paisas also in calculations. Previously we have the paisa, 10 paisa, 25 paisa, 30 paisa, 50 paisa, like we have it. Okay. 1 rupee you can represent it as 1, but I will give it to you 50 paisa, then how you are going to represent it? So, now we are using the decimal system, okay, as we have tens, hundreds, thousands, 10,000s, lakhs, 10 lakhs, crore, you have the system and a decimal system. Like in decimal system also we have another one, if you say less than, so here 10, 100, 1000, 10,000, like, so you can say 1 by 10, 1 by 100, like. So, there we are using that, we have to represent like 0.1, 0.01. This is called the decimal system. Okay. In the decimal system means here you can divide, for example, 1 by 2. You want to represent this 1 by 2 in decimal system, you can write it as like 0.5. So, it is very clear. So, I think so it is not necessary to explain how 1 is divided into, when 1 is divided by 2, it is how it is 0.5. So, you know it is very clear. So, that is the reason I am not explaining how it is 0.5. Okay. For example, if you say 1 by 4, you can write it as this is 0.25. So, means when you make a fraction into decimal system, there is an end. So, we call it as this one as a terminating decimal. So, there is an end, it is 0.5, it is 0.25, there is an end, it is a terminating decimal. Okay. For example, I gave one apple to you or one chocolate to you, I ask you to divide it into 3 equal parts. Is it possible? Can you divide? If I give one chocolate, I ask you to divide in 2 equal parts, you can divide it easily, okay, and we can say it is a 1 by 2 each one. When I ask it to you 1 divided into 3 equal parts, I am asking about 3 equal parts. Can you divide in 3 equal parts? It is quite impossible, you can't divide. Just have a look at this. For example, divide 100 rupees in 3 equal parts, 33 rupees, 33 rupees, 33 rupees. What is 33, 33, 33, which is 99. What about remaining 1 rupee? You have to divide that 1 rupee again into 3 equal parts, means 33 paise, 33 paise, 33 paise. You have one more, 1 paise more. You divide it into 3 equal parts. When you divide it into equal parts, is there any end for this process? Nothing. So, continuously it comes as, when you divide 1, it comes as 0.3333 and so on. There is no termination for it, it is a non-terminating fraction. And here one more important point is, here 3 is recurring, continuous, 3 is continuously coming, so recurring. So, we call it as it is a recurring fraction. Terminating, you are listening so many words, terminating fraction, non-terminating fraction, recurring fraction. Okay, I will bring out one more very important fraction to you, very familiar number, and you have to know about that. That is simply we call it as pi. when you take the pi value, it is 3.14 and so on, and one so on. So, even our greatest Indian mathematician Ramanujan finds up to 1 lakh digits, and it is neither recurring or terminating. So, non-recurring, non-terminating. If you find, for example, root 2, the value of root 2. For example, I gave one problem to you. Let us take a square of 1 unit length. When you take it as square, what is the length of the diagonal? Simply you can say it is root 2 units. Can you draw a line of exactly length of root 2? It is very difficult. By geometrical sense you can draw it, but if you want to say, if you want to express the exact value, it is because you can't find it the value exactly, because it is a non-terminating and non-recurring. So, where this kind of numerals are we find, simply we call it as this one is, that is a rational. So, it is completely, it is a of course opposite property of that, which is called as irrational. So, irrational number. Okay. So, irrational number, what is meant by irrational number? What you understand from this? A number which is non-recurring, non-terminating, simply those numbers are called as recurring, irrational numbers. Okay. So, we have rationals, we have irrationals. When you consider both, we call it as real numbers. So, today you are going to learn the very important concept, which is useful and which is directly connected with our daily life situation, that is called real number system. Take any chapter in our mathematics, it is directly or indirectly connected with the number system. Is it clear? So, once again I am going to revise this, all these things what I said as a notion. We have the numbers, natural numbers, which are generally used for counting. So, we call it as a counting numbers, which start from 1, 2, 3, 4 and so on. And when you consider nothing or empty, which is represented by 0, so when you include 0, then including 0, the natural number system is called as upgraded as whole number system. When you represent with some property which is downwards, less than or anything like, then we can represent those numbers as integers, means there are some positive numbers, negative numbers and 0. Here do not forget this, there is no existence of the negative numbers or positive numbers, this sign only gives the property. Okay. Then if you want, there is a possibility of the fraction, we call it the fractional numbers. So, when you consider the whole and fractions, simply we call it as rationals. So, we can convert the rational numbers in terms of decimal system, decimal numbers. In the conversion of decimal numbers, we can identify two kinds of numbers, which are recurring numbers, which are terminating numbers, and of course, some other property which are non-recurring, which are non-terminating also. We can give a flow chart simply as, okay. So, which are non-recurring, non-terminating, we call it as irrational numbers. The rational numbers and irrational numbers both are called as simply as a real numbers. Okay. So, I will give a small tabular form. See here you have to write it as what is it, whether it is a rational number or irrational number, all this. Before going to that, I want to show the history of numbers by using some slides. So, just you can see the history of the total number system I collected for you. Just go and observe the system here. So, when you go for the system, you can identify clearly. Okay. So, here I given that where did the numbers originate. See, thousands of years ago there were no numbers to represent 2 or 3. Instead of those numbers we are using the fingers, rocks, sticks